Crash Course Instrumentation presents Episode 62, Parallel Circuits, the Wrap-Up Checklist and Challenge, Cold Open. Today we wrap up the Parallel Circuits series with a speedy checklist, a simple way to collapse mixed networks, and a short challenge so you can prove it to yourself. Section 1. The 3 rules you must remember. Same voltage across every branch. Branch currents add to make the source current. Adding branches lowers the equivalent resistance measured in ohms, O. Series contrast. Same current through every part, voltages add, and adding parts raises the total resistance measured in ohms, O. Section 2. The speed solve checklist. Use in this order. Identify the 2 common nodes that all branches share. List branch resistances in ohms, SO, and note the one with the smallest value because that branch will carry the largest current. Write the source voltage, so you remember that every branch has that same voltage. Compute only what you need. If you need the total current, find each branch current as voltage divided by resistance, and then add them. If you only need one branch, do just that one. Collapse the network. Reduce any series parts inside a branch first. Then reduce branches in parallel. Repeat until a single equivalent resistance remains. Check the answer. The total current equals source, voltage divided by the equivalent resistance. The sum of branch currents must match that total. Section 3. Mixed series parallel in plain words. Inside a branch, add series ohms O together before you do anything else. Between branches, combine in parallel. The equivalent resistance is always less than the smallest branch. Reality check. If your equivalent resistance comes out greater than the smallest branch, something is wrong. Section 4. Troubleshooting flow you can trust. Step 1. Measure the source open circuit voltage, then measure under load. A large drop points to the source or the wiring, not the loads. Step 2. Isolate branches. Pull or open one branch at a time to see whether the dimming or the fuse trip stops. Open branch signs. One device off while others look normal. Source current falls. No protection operates. Shorted branch signs. Sudden voltage sag. Several devices dim. Protection operates or conductors overheat. Protection sanity check. Each branch must have the correct fuse or breaker size and the correct wire gauge. Section 5. Measurement without mayhem. Voltmeter across. Ammeter in series. A clamp meter goes around one conductor only. Meter loading. Your voltmeter is a very large resistance in parallel. Keep its input at least 100 times the resistance it measures to keep error under about 1%. Ammeter burden. A small internal shunt adds a tiny voltage drop. It is usually small but can matter in sensitive branches. Section 6. Design cheat codes you will actually use. Make a custom value. 2 resistors in parallel, create a resistance lower than either one. Equal values make half. Share heat. Parallel equal resistors to divide power. For example, 2 quarter-watt parts act like 1/2 watt part when current divides evenly. LED branches. Each branch needs its own small series resistor to stop current hogging. Parallel sources. Only when voltages match closely and each branch has a fuse. Small balancing resistors or diodes help sources share current instead of fighting. Section 7. Quick example in words. No formulas needed. A 12-volt source feeds 3 branches, 30 ohms, O, 60 ohms, O, and 120 ohms, O. Each branch sees 12 volts. The 30-ohm branch takes the largest current, the 120-ohm branch the smallest. Add the 3 branch currents to get about 0.7 ampere total. The equivalent resistance is about 17 ohms, whoa, because 12 volts divided by 0.7 ampere is about 17. Total power is voltage times current, about 8.5 watt for the whole network. Section 8. Challenge you can pause on. Challenge A. Replace the 60 ohm branch with 2 resistors in series, 10 ohms, O, and 50 ohms, O. Decide whether the total current goes up, down, or stays the same, and why. Challenge B. Your voltmeter reads 12.6 volts with no load, but 10.8 volts under load. Explain what that says about the source or the wiring before you touch any load. Challenge C. 2 5-volt supplies in parallel feed 3 amperes. Describe one safe way to encourage even sharing. History bite. From lamps in series to reliable homes. Early street lighting used series arc lamps. If one lamp opened, the whole string went dark. Domestic wiring moved to parallel branches, so each lamp received full voltage and worked independently. That simple design choice, plus selective protection, made electric power reliable at scale. Recap: same voltage currents add, equivalent resistance falls when you add branches. Troubleshoot in this order: source health, isolate branches, verify protection and wiring sizes. Measure without disturbing the circuit and design for safe sharing. Outro. If this series helped you reason faster and stay safer, subscribe so you never miss the next crash course instrumentation topic. Special thanks to Tony Kuphaldt and the open source community for making world-class learning freely available to everyone.